I think we can start. So, welcome everybody. My name is Ferdinando Papale, and I am a .NET developer at MongoDB here in Copenhagen. And the reason why I'm here is that I would like to tell you a little bit about why we decided to move from using IL weaving to sort generators in the .NET SDK of Realm. So, have you ever heard about Realm before? Okay, one person, I think, at least is shaking his head. So I will tell you more about it later, but Realm is an object-oriented database that is mostly targeting mobile. And we're going to see why we're using this in the first place, why we're using this technique in the first place, and why we decided to move from one approach to the other. So just to set up the context, we are going to talk about code generation in .NET, code generation and alteration. This because both IL weaving and sort generators are two different techniques that can be used to add code and modify code. And so we're going to see why we decided to use these techniques in the first place, and then why we decided to move from one to the other. But first of all, we need to take a look at these techniques. So first of all, IL weaving. Have you ever heard of IL weaving? Couple of persons. 4. Perfect. So every time you compile your C# code, it gets compiled first to something called IL. That stands for intermediate language. Then, depending on the configuration, it either gets converted to machine code at runtime, if you're using the now old just-in-time compilation, or it gets compiled ahead of time if you're using AOT. But the idea is the same. So you have this IL code that looks like high-level assembly practically, that is very similar to bytecode if you're used with Java. IL weaving essentially is the process of modifying the IL code in some ways. And I also wrote on the slide that it almost feels like magic, because practically with IL weaving you can do practically anything. So you can add classes, modify how the code works, you can add attributes, remove attributes, and so on. And one important thing to remember about IL weaving is that this is a process that happens after the compilation. So this means that everything that is done by the weaver, you cannot see it in your IDE. It's something that you cannot see out of the box. And it also means that because this needs to happen after the compilation, your code needs to be in a compilable state. You cannot leave it in a non-compilable state and then hope for the weaver to fix some problems for you. So why would you use a weaver? Why would you use usually a library that has a weaver inside? Well, it's very useful to generate repetitive or optimized code. For example, just to give you an idea about how IL code looks like. So if you have a simple class with a property, with the getter and setter like the one that you see on the left, the one that you see on the right is the IL code corresponding to the getter on the top and the setter at the bottom. It doesn't really matter that you understand everything, but it was just to show you how IL code looks like. It's a series of instructions practically, and it's not really easy to read. Okay, now to give you maybe a more practical example of a use of IL weaving. So if you ever had to work with any MVVM framework like Maui, Xamarin, Avalonia, Uno, and so on, you know that if you have a view model and you want to show something in the UI, usually what you do is that you bind some classes to the UI, some objects. And in order to do that, you need to, your class needs to implement iNotify property change that has one event that is this property change event. The idea here is that your object should raise this event every time a property changes. So if you had to implement this yourself, what you will do is that your class from this will look like what you have here on the right. So what will need to happen essentially is that you will need to modify the setters and getters of the properties so that every time the setter is called, if the value is different than the previous one, then in this case it's calling this on property change that is invoking the event in the end. Now, you can imagine that this is a lot of boilerplate code, especially if you have a lot of properties. It's annoying to write. You need to remember to use the right name for the properties. And also it's annoying, especially if you have, for example, dependent properties. So if you have, for example, a full name property that depends on the first name and last name, then you need also to take care of that. So what this property change.fody does essentially is do it for you. So it goes into your DLL after it has been compiled. It finds all these classes that are defined as implementing iNotify property change, and then it's modifying the setter and getter so that it does what you see here on the right, essentially. So it's invoking the event with the correct name of the properties. And this also works for dependent properties. So one thing to realize is that in your IDE, you will still see only what you see here on the left. What you see here on the right is the behavior, but this is not something that you're able to see, at least from your IDE. And yes, so now how do you see IL code? How do you see Swift code? Well, it really depends what do you want to do. If you want, for example, you're just curious about how IL code looks like for a simple snippet, you can use something like sharplab that is useful for a lot of different things, but it's an online .NET playground. And essentially, you just write here on the left, and then on the right, you see the corresponding IL code. And for example, here, you can see the getter of the name property, and if you over the body, it will also highlight it on the left. So this is just if you have like a small snippet and you're curious about how it looks like. If you have a project that is using a library that is using weaving, and you're curious about what this library is doing to your code, then you need to use something like a decompiler, like ILSpy. So for example, here I have a simple project that has this person property change that is declared as implementing iNotify property change. And as you can see, it just has a name, an age, 2 automatic properties. I didn't modify the setters and getters in any way. The only thing that I did to this project is that I added this library that I've shown you before. So property change.fody. Now we need to compile it. And then we need to open our ILSpy, that is a decompiler. And then you need to open the DLL. Then you navigate in the DLL, into the models in this case, and you have this person property change here. Now, what you see here on the right is the IL code. It's not particularly nice to see, so what you can do is that you can select the C# code so you see the decompiled code. And now, if you try to open one of the properties, you can see that they've been modified. They've been modified so that if for example, if the new name is different than the previous one, then it's calling this onProperty changed. And if you look at this method that has been also added by the weaver, then you see that it's just invoking the event. So as you can see, this is not really visible from the IDE. So this is all, you can see it only if you're using something like a decompiler. And this was just to give an idea about how to look at the effect of weaved code. Okay, so search generators. Who has heard about search generators? More people, yes. So this is a compiler feature that was added in .NET 5, and essentially search generators are a part of the compilation pipeline. So when you have a search generator in your project, what happens is that you have a first step of the compilation that is going through the user code. Then what happens is that there is this search generator step of the compilation. So the search generator receives something called a compilation object that allows it to look at the user code from the syntactic level, the semantic level, and so on. And then eventually, the search generator can add new code back into the compilation. And after this process has been done, then the compilation resumes. So essentially, search generators can emit source code. There are two biggest differences between search generators and weaving. And they are that, first of all, search generators are part of the compilation pipeline. So they are inside the compilation, while weaving is something that happens after the compilation. And another thing is that search generator they cannot modify source code, they can only add the new source code. So they can also fix some things that if you left your code in a non-compilable state, if you have a search generator, then it can fix certain things. So Why are they useful? They're useful for the same reason why weavers are useful. They're very useful to generate repetitive or optimized code. For example, system.text.json, that is probably the, let's say, default library for serializing and deserializing JSON, started using a third generator in .NET 6, I think. So the way that it works is that you define your class as normal. Then somewhere else in your code, you need to have this class, this partial class that is important, that is deriving from the JSON serializer context. And then you need to decorate it with these attributes that contains the type that this context should be responsible for. What the third generator is doing essentially is going into your code, finding this partial class, and then continuing like adding another file with the rest of the implementation of this class. And then when you need to serialize it, you need to pass this context. The details are not really important, but the important question is, why did they decide to add the third generator? Well, historically, the process of serialization and deserialization is something that has been done, mostly serialization, with reflection. And it's been done with reflection because at runtime, you can discover which property an object has, and so you can act on it. But if you think about it, you already know all the properties that an object has at compile time. And the reason why we use this library is because we are lazy, and we don't want to write the deserialization ourselves. So what this library is doing with the third generator essentially is writing out the serialization already at compile time. So this is much more performant. And according to the performance, this is at least twice as the reflection-based approach. Okay. So how do you see third-generated code? Well, this really depends on your IDE. If you, for example, you're using Visual Studio for Windows, you need to go into your dependencies under analyzers. Then maybe it's a little bit confusing. Then you find the library that has the third generator, and then under that, all the generated classes that have this beautiful banner that tells you that the class is third generated, so you cannot modify it. But it really depends on the IDE. For example, in the now defunct Visual Studio for Mac, you couldn't see it. You always have the possibility, actually, because all these files are not on your file system. They are just in the compilation. Actually, if you change some configuration in the project file, you can always put them on the file system, but you need to be a little bit careful about it. Okay. So now you know about weaving, now you know about third generators, you need to know a little bit about Realm. So Realm is a reactive, object-oriented, and cross-platform database that has been created mostly targeting mobile, so devices with low capabilities. It's available for other programming languages like C#, Kotlin, Swift, and so on, and a lot of different platforms. And it has a lot of nice features, including the ability of synchronizing between multiple devices and with Atlas, so MongoDB in the cloud. But there are two features that are really important for the rest of this talk. So first of all, Realm is object-oriented. And what this means that when you're working with Realm, you're working with C# object. And there is no translation layer. So it's not an ORM where you have SQL underneath. It's its own database, and the shape that your object has in C# is the same shape that it has in the database. There is no translation layer between the two. And this is one thing. And the second thing that is super important is the fact that Realm objects are live. In this case, live means that the object always reflects the latest data stored in Realm. So we'll see it in a second, but when you have a Realm object and you get the value of a property, you're getting this property directly from the database. If you're setting the value of a property, you're setting this property directly in the database. This is very different than other approaches, for example, that use SQL underneath, because if you do a query with SQL, the objects that you get, they reflect the state when you did the query. And that's it. If you modify this object, then you just modify this object. You didn't modify what's in the database. And yes, and I wanted to show you just a small example about this, just to give you an idea. So I think should be visible. Okay. I have a small example here, and maybe going line by line. So here I'm just creating an instance of the database. One second. With this realm get instance. Then I'm creating a GUID just that I'm using as a primary key. And then I have this block with the realm.write that is the equivalent of a write transaction in another database. And then I'm adding a person, where the ID is the ID that I just created, the name is Mario, and the age is 22. Nothing too crazy. Then I have two persons, person 1 and person 2. And the reason why I'm doing it twice is that now person 1 and person 2, they are two different objects. Okay? Two different objects, but they found the same person with the ID that I created before. Then I have a new write transaction where I'm changing the age of person 1 to 40, and then I'm printing the essentially the age of person 1 and then the age of person 2. Now okay, I hope it's visible, but so maybe this is not surprising that the age of person 1 has changed, because I just changed it in this line here, and it's equal to 40, while before it was 22. The thing that maybe is a little bit strange is that also the age of person 2 changed. And the reason for that is that, as I said, realm objects are live. So when you get the value of a property, the property is coming directly from the database. And I can assure you that person 1 and person 2 are not the same object in the managed code. But you have to believe me on that for now. Okay. So now you have an idea about what is weaving, you have an idea about sort generators. Now you need to understand why we decided to use this approach in the .NET SDK of Realm. So first of all, let's take a look at why we started using weaving. So what you see here on the left is the way that developers could define their data model. So you just define a simple C# class, you define properties with setters and getters. There are some attributes like primary key, because this is a database. And then the important thing is that they needed to derive from something called realm object. And what we're doing with weaving in the beginning, essentially what you see here on the right, we were going into the user DLL. We were finding these classes that are deriving from realm object, and then we are changing the setters and getters to call getValue and setValue. Without going too much into details, getValue and setValue are what allow the objects to be live. So when you call getValue, you're getting the value for this property from the database, and when you're calling setValue, you're setting it into the database. One thing to remember about this is that this is an extremely simplified version of what the weaver is doing, because what is happening depends a lot on the state of the object. For example, if it has been added to the database or not. It depends on the type of the property and so on. So if you look at it, it can be much more complicated than this. So why we started using weaving? Well, we started using weaving essentially to improve the developer experience. We wanted developer to use a normal C# object without needing to worry about calling getValue, calling setValue, needing to worry about the state of the object and so on. So essentially what we're doing with the weaving is that we were hiding a lot of the complexity of the library, of the internals of Realm from the user by using this weaving, because they just use normal properties with setters and getters, and there's a lot of stuff that is happening behind the scenes. So just to give you an idea about what is happening with the, let's say, simple string property. So what you see here on the left is the way that your IL code looks like if you open a project and you just write a getter for a string property. And on the right, you see how it looks like if this if this was actually after the weaving process has been done. And this is just for a simple property, because if you have a collection, for example, it becomes much longer. Okay, so as I said, weaving has been extremely powerful for us because it allowed us to hide a lot of complexity from the final users behind the model definition. But it also has quite some drawbacks for us. So first of all, as you could see, I think we can all agree that the IL code doesn't really look nice to read. And if you don't have experience with it, it's really difficult to understand what is happening. So for this reason, it's very difficult to extend the Weaver, because you really need a lot of specific knowledge. And we were lucky that this kind of, like the Weaver was a specific part of our source code. So it's something for which we didn't need to touch many times. But for example, you need to touch it all the time that you are adding support for new property types, for example. Another problem is that essentially this is a black box. So you add Realm to your project, you try to use getters and setters, and it works like magic. That it's nice, but developers don't really know what has happened to their properties. And there's also another problem, the interference. So this is a process that happens after compilation. And because you can modify anything you want with a Weaver, if you have multiple Weavers or multiple libraries that are using Weavers, then the result could depend on the order of the Weaver. Just to give you an example, this property change.fody that I talked about a second ago, this one here. So they implement iNotify property change. They not implement, they call notify property change. And this is also something that we need to do, that we also provide, because Realm is reactive. So we had to work in a way that we don't stomp on each other. So we put a certain attribute so that that library knows that they don't have to touch setters and getters anymore. Another problem is that essentially this is not debuggable. It's not debuggable because this happens after compilation. Your IDE has no idea what has happened. And also, it could leave your code in a state where if you run it, you will start getting strange errors. Okay, there is another big issue with weaving, is that weaving is not part of compilation. So a lot of developers asked us, well, why do Realm objects need to derive from a base class? Why couldn't you use an interface? That is a very reasonable question. And the reason is essentially this. So weaving happen after compilation. So the code needs to be able to compile in order for the Weaver to do something. And if we had to have an interface, like here, instead of a base class, this means that all the model classes that the user define will need to implement this interface. Maybe just right-click, implement interface with all these beautiful exceptions. And then we could go into the user code and then change the behavior of the properties, of the methods, and so on. But we decided to go against this for a couple of reasons. First of all, it's horrible on our point of view, I mean from the developer point of view, because this means that now you need to implement also all these properties in IL. That is very difficult to work with. But especially, this is a super bad experience for developers. I mean, if you had to use a database, and for each of your model classes, you had to have this horrible stuff, you probably wouldn't use it because this looks just impossible. And also, it feels super magical because you have all these not implement exception, then you run your code, and boom, it works. So we decided to go against this. Okay, so now, at a certain point, after .NET 5 come out, there was the support for source generators, and we decided to take advantage of them, to try to go away from weaving. This was also a time that where we decided to modify slightly also the model definition. In particular, what you see here on the left is the classic model definition. So the one that I've shown you before, where you have your class with the properties, setters and getters, and so on, and then the base class. And then on the right, you have the new model definition that is based on source generator. So you have the only difference is that you have now a partial class, and instead of having a base class, we have an interface. That is also what developers wanted. But the property definition is 100% the same. So essentially, moving from the previous approach to the new approach is super easy for developers. Why this class needs to be partial? Well, for the same reason why it needed to be partial in the JSON library. Essentially, what we're doing is that even though you're not implementing all the properties and methods that are on this interface, a Realm object, we add the new file that essentially contains all the implementation for you. But the important thing to know is that this is essentially a win for us, but for developers, this has 100% the same behavior as the woven approach. And just to give you an idea, this is, for example, what the search generator is generating for a simple class. And this is like much, much longer than this, because there are different classes that are being generated. There is a lot of other things that are happening. And an important thing that I forgot to say is that Realm is open source, so you can go on GitHub and look at this, and if you're curious about something, we can talk, but also you can just take a look on GitHub. Okay. So we think that the move to search generator was super nice for us, because search generators have a lot of advantages over IL weavers. So first of all, the code that you are generating is essentially readable, because it's just C# code. You should be able to read C# code. And it's also something that you can read from your IDE, and it's debuggable. It's also much nicer to work with search generator, because what you're doing is that, apart from the Roslyn API and how to analyze the user code, that is annoying, maybe, but you're just generating C# code, so it's much easier to reason. And also for this, it's much more extensible. So this allowed us to add support for some features in a much nicer way, in a faster way. For example, support for nullability. And also, this is part of the compilation. Being part of the compilation, you don't have to fight with other search generators, and this is part of the, let's say, official compilation pipeline, differently from weavers. There are also some problems with search generators. So the text generation is more like an annoyance. So if you're just generating a source file, you're just generating a text file, right? And so if you want developers to look at it and they look sloppy, you need to take care of formatting, because you have some basic formatting that you can use, but it's not super nice. So you need to take care of it. It's not a biggie. Another problem is the performance, and this is because search generators essentially are running as you type. They're not running actually only during the compilation, because for the reason that I've said before. So you are, for example, in this case, we have an interface, and the search generator needs to run. Otherwise, you will have a compilation error, because your IDE will complain that you don't have the implementation of the interface. So you need to take care of making your search generator work in the least amount of work that it can do. There are also not so new anymore, but there is also incremental generators now that are search generators that try to cache some parts of your work. But this becomes much more problematic if you have a search generator in a bigger project. And there is a big issue with search generators, at least for us. And the problem is that search generators are only additive. They can only add things. They cannot modify what is already there. And this means that I kind of lied to you, and we didn't completely remove IL weaving. Why is that? So what you see here on the left, this is the model definition with Weaver, the one that I've shown in the beginning. You have your class, you have your base class, and so on. And then you have your properties. Now, if we wanted to move to a 100% source-generated approach, then the model definition will look like what you have here in the middle. So we have the partial class, you have the interface, and then we cannot let the user define the properties themselves. And we cannot do it because search generators can only add things, and if the property is already there, we cannot add a property with the same name. And so we will need to use an approach similar to what, for example, MVVM Toolkit does. If you have been to the talk yesterday, they've also talked about it. So what they do, and what we could have done, is that we could have let developers define some private fields with an underscore, And then we could go and then define, and then in the sort generated file, we could go and essentially implement the properties with the same name. This is something that we could have done. We decided to go against this for a couple of reasons. First of all, moving to the previous approach, to this approach will require much more work, because before you had properties, now you have fields, so more work for developers. Then we will need to have, for example, more attributes, because Realm supports properties that can be private, protected, public. It doesn't matter what is the accessibility. So this means that developers will need to tell us what kind of properties they want to define. And another problem is that, for example, for MVVM toolkit, the fact that they are using this approach makes much more sense, because these fields, in the end, they end up being used as the begin fields of those properties. While in our case, these fields will not be used. So essentially, they are just a blueprint and will just be there, and it doesn't make much sense. So overall, in order to keep the same level of developer experience, we wanted to keep the same kind of magic. Let's say we decided to go for a mixed approach that I've also shown you. So the one on the right, where the property definition is the same as in the beginning, and the only thing that developers need to do is to add this partial attribute modifier, and then they need to have this base interface. Okay, so what is the weaving doing? What is the weaving doing now? So the thing is, with the weaver now, what we're doing with the weaver now, essentially, is that we are still modifying the setter and getter, but what we're doing is what I'm showing here on the right. Essentially, the setters and getters of properties now are just going to a property with the same name on the accessor. And the accessor is something that is also sort generated. So one thing to remember is that this looks like a lot what I've shown you in the beginning about what we're doing with weaving. But what I've shown you in the beginning with weaving was an extremely simplified version, while this is 100% what happens for every property. So there is no difference between the property types, there is no difference between the state of the object and so on. So this is much nicer to work, much nicer to do with the weaver. And you have to believe me on this, because it is like a couple of lines, let's say. And so practically what we have done is that all the complexity that we had in the weaver, all these if, else, depending on the property type and so on, now are in the accessor. But the accessor is something that we sort generate. It's something that is generated together with the implementation of the interface. So this is much nicer to work with, because this is something that we write ourselves. Okay. So just to give you an idea about how all of this went out. So we worked on this for about 6 months. And during this time, we didn't work only on this, and also we needed some time to change the way that our, let's say, our internal work, because we were used to working with the base class, and now we had to use an interface. So we had to modify quite some things in our source. And we published the first version of the source generator in November 2022, where we had a package called realm.sourceGenerator. If you look at it nowadays, it doesn't exist anymore, because we decided to add the source generator directly into the base library. We still support the classic model definition, but it's something that we are trying to push developers for to use the new source generated approach. And overall, this allowed us to add new features to the SDK, like, for example, support for new data types and for nullability in the model definition. We're also planning to do several things to the source generator, including this incremental generator. This is something that we didn't do yet, because we didn't receive any complaints about the performance of the source generator, but it's something that we still want to tackle. And there is another thing that we'll really like to do, and that is completely remove IL weaving. So this is like the first time that I have like a modified version of this slide. because in order to completely remove IL weaving and to keep the same level of, let's say, to keep the same model definition, the thing that we will need was partial properties. And this picture, this screenshot here was a screenshot that is in the C# language repo, where they were asking for the partial properties. And this is something that was getting more and more support as Source Generator came out, because it's true that, I mean, it's not such an uncommon use case, the need to modify the way their setters and getters are acting. And because Source Generator is something that is here to stay, especially with AOT and a lot of other things, this was gathering more and more support. And finally, in C# 13, we are getting partial properties. And this is super nice, because before this, another way that maybe we could have gone around this will be using interceptors that look much worse to use, to be honest. Another thing, though, about this is that it's true that C# 13 is going to support partial properties, and we're going to support them, but the problem is that we also need to support older version of C#. We need to support older version of .NET, so we support even .NET Framework. So this is something, this is more like a long-term plan, because we cannot simply drop support for older version and get done with it. But it's like a long-term plan. Okay, so just to sum everything up, so code generation has been an extremely powerful technique for us, because it allowed us to hide a lot of complexity of the internals of Realm behind the model definition. In the beginning, we were using IL weaving for this. That is an extremely powerful technique, but is also very annoying to work with. For this reason, we decided to move to Source Generator that are nicer to work with and are more modern, and also are essentially what is being pushed by the ecosystem. So we believe that the support is going to be there. They all have their own quirks and limitation, but overall, we think that this has been a very good change, because even though the developer experience is very similar, it also really improved our work, especially in regards to certain part of our source code, especially regarding the model definition. That is obviously is only a part of what we work with. So overall, we think that the switch was definitely worth it. We can see that we are much more able to add certain features, and the developers didn't complain. So overall, I think it was a good decision. And that was it. So if you have any questions, if you have more, if you want to know a little bit more about Source Generators, weaving, and so on, I put some links here. And the link is also underneath. And also, there are my colleagues at the booth in the hall. So they are ready to answer your questions. And yes, that's it. Thank you. And if you have questions, I can take questions. Otherwise, we can also talk later on. You can stop me wherever you want. Any questions? We can also talk privately if you don't want to. Thank you very much.